What if you have the sequence of inverse tangent of ln of n? Is this convergent or is this a divergent sequence? Let us take a limit of an. The limit of an as n goes to infinity, we are interested in end behavior of the sequence. Is the limit of inverse tangent of ln of n as n goes to infinity. Remind yourself of the behavior of inverse tangent. For inverse tangent of n, the graph is discontinuous. So if you look at the inverse tangent graph, the graph of inverse tangent is like this. It's rather like a dot than line or curve. So inverse tangent of n as a sequence has dotted curve. This is discontinuous. This is different from the inverse tangent of x in the sense that when you're working with inverse tangent of x, x can take on any value, and then the graph of inverse tangent of x is continuous. It means that there is no dot involved. You can continuously connect these together. That's the main difference between a sequence and a function, especially when it comes to the graph are in the form of dot. It's not very precise, but it gives you the idea behind a sequence and a function graph, a continuous function graph. So if you look at the inverse tangent, the limit of inverse tangent of x as x goes to positive infinity is pi over 2. As x goes to negative infinity, it's getting closer and closer to negative pi over 2. So basically you have the following limits. The limit of inverse tangent of x as x goes to positive infinity is pi over 2. So you can say that, hey, the limit of inverse tangent of n as n goes to positive infinity is pi over 2. And the limit of inverse tangent arctangent or inverse tangent of x as x goes to negative infinity, it's getting closer and closer to this line down here is negative pi over 2. So the same thing for your sequence. The limit of inverse tangent of n as n goes to negative infinity, it is equal to negative pi over 2. Let me make sure I write everything clearly. So why we are using this? The limit of an as n goes to infinity is equal to the limit of inverse tangent of ln of n. But you can move the limit inside parentheses in the sense that you're working with inverse tangent of x. So you have inverse tangent of limit of ln of n as n goes to infinity. But when n goes to infinity, the behavior of ln of n is like this. So for the graph of ln, here you have the graph of ln of n in dotted line, dotted form. That's the main difference between a continuous function and a discontinuous function. So ln with dotted graph, this is ln of n versus ln of x, which is continuous. So the limit of ln of n as n goes to infinity, goes to infinity. There is no doubt there. So this, the limit of an as n goes to infinity is equal to the limit of ln of n inside inverse tangent, which is indeed equal to infinity. Well, the inverse tangent at infinity is equal to pi over 2. So what's the conclusion? Since the limit exists and it is a unique numerical value, so the sequence converges to pi over 2. So we have a convergent sequence, everybody.